we learned about how breadboard helps us build circuits, and it's usually used for experimental type. And as you see here, I'm using green LED. It's my second favorite color, and I want to change it up a bit. And I'm using a 220 ohms resistor. But what happened if I change 220 ohms right here to 10 kilo ohms or 10k ohms? So let's disconnect the battery for a sec. Once you disconnect the battery, electricity stops flowing and the LED stops lighting. So let's take that out and put 10k ohms here. Just connect it to the LED and then let's just reconnect it and it looks dimmer. Why is that? Why when I connect a higher ohm resistor or resistor with a higher resistance make the LED dimmer and not brighter? Well, I'll explain that in this video. Hello everybody, this is King Tut here and welcome to your 6th Electronics 101 tutorial. In this tutorial, I'll teach you guys about Ohm's Law. So, the history of Ohm's Law is discovered by a German physicist named Georg Ohm, and he believes that current through the conductor is proportional to voltage or potential difference. So he worked in a Jesuit college and he published that paper and it was rejected by him, so he resigned, worked at a polytech college in Nuremberg, and he published the same paper and he got awarded. So it's crazy how different colleges are sees things in a different way. So it's, I mean, good for Georg Ohm. And don't get confused by ohms as in resistor ohms and Ohm's law. So ohms is the unit of measurement for resistor. And Ohm's law is the one that I'm going to be actually showing you in the next slide. So Ohm's law is V equals IR. It's a famous equation used by many electrical engineers and electricians and basically anyone who just does circuits. So V is voltage, I is current, and R is resistance, or basically resistor. And it's constant unless there's a potentiometer. If there's a potentiometer, then R is a variable. And potentiometer is another way of saying that R can change through basically twisting and turning that knob. Alternatively, if you want to find current, you do a little bit of algebra and it becomes voltage over resistance. And if you want to find resistance without actually burning the resistor, because the only way you could burn a resistor is if it exceeds, if V and I, if voltage and current together, power, exceeds the resistor's power rating. So if you want the amount of resistance with that goes a little bit high or a little bit below or probably below a quarter, then then you use voltage over current. The higher the resistance, the lower the current, and the lower the resistance, the higher the current, and also the higher the power, that which means it's gonna end up burning the resistor. So let's go to the next slide. And voltage and current equivalence. You guys might hear resistance equivalence, but nobody actually talks about voltage and current equivalence. When its voltage is the same in circuit and when its current the same. So current is equal or the same when resistors are in series. So right here, that's when resistors are in series. And I'm going to show you how to calculate equivalent resistance in the future in this series, or probably in different series. But there's going to be a video out there explaining resistor equivalence. So voltage is equal when resistors are in parallel. So at that, what it's called node here, I'm going to talk about different parts of circuits in the circuit tutorial. So I'm going to be making a new series called Circuits, and that's where I'm going to be talking to you guys about different parts of the circuit. So voltage is equal at that node. So that junction right here is called a node. And voltage splits and goes down in series resistors. So if, let's say this is 9 volts here, it's going to go lower than 9 volts, and it's going to take this amount of volts in between first resistor and second resistor, or R1 and R2, and it's going to go through R2, and it's going to be less than the voltage between R1 and R2. And when resistors are parallel, current splits. And this is because of KCL. So I'm going to be talking about that in another video. I'm going to talk about KVL as well in another video as well. So when current goes to that node right here, it splits. It splits into 3 different currents, and usually it joins at the end. So the first example here, say you have 220 ohms resistor and a 9-volt battery, and it wants you to calculate the current flowing through the conductor. So you use Ohm's law, you plug in the value or replace V with 9 and replace R with 220, and you get 9 equals I times 220, with current being the unknown variable. I is the current. So using algebra, you get I equals 9 over 220. So if you see, so previous slides, it's basically I equals V over R. So V is 9 and R is 220. And then finally, through division, you get I equals 0.0409 amps, or I equals 40.9 milliamps. So will a 40.9 milliamp be enough to burn a 1/4 watt resistor? So you use power, and power is V times I. And so if you don't know that, check out my voltage and current tutorial in Electronics 101 series. It's going to be in the card above or link in the description. So P equals 9 times 0.0409 equals 0.368 watts, or 368 milliwatts. So it's a little higher than 0.25, so it's not going to burn a resistor quickly. It might burn it slowly, but or probably not burn it at all. If it's like dramatically higher, like a watt or 2 watts, yes, absolutely yes. So let's do another example, but with LEDs. So say you have 220 ohms resistor and with 50 ohms LED and a 9-volt battery, and it wants you to calculate the current. So you add 220 ohms with 50 ohms together since they're in series. So usually series resistance, you add them together. So you get 235 ohms all together. And then you use Ohm's law. It's the same thing, except instead of 220, you use 235 in place of R. And then through all this algebra and division, you get I equals 0.0383 amps, or I equals 38.3 milliamps. Well, this amount of amps enough to burn a 1/4 watt resistor. So it's the same thing with power, V times I, and you get 344.7 milliwatts. So it's also maybe it's not gonna burn, probably might burn your resistor slowly or just not burn at all. And like I said, if it's like 1 or 2 watts, absolutely yes. Thank you so much for watching. If you really like my videos, comment down below, and I will see you in the next video. Bye.